Here we are in lesson 2 of unit 2, and this lesson is called temperature. And the simple essential question is, how is temperature related to kinetic energy? And if you remember from our last lesson, that kinetic energy is the energy of motion and that potential energy is stored energy. This is the standard that we are working on in this unit. So, to talk about the changes between kinetic and potential energy and how energy transforms or changes forms, temperature, heat, and heat transfer. Just like every lesson, we start out with an engage your brain page. So, pause the video, take a moment, and fill out your engage your brain. The very first question asks you true and false, and then the second question asks you to illustrate what would be the difference between a warm and cold for you. And then the third question asks you to use the table of Greek meanings and the context sentence they've given you and to come up with the definition of what a thermometer is, and then to write a sentence using the word thermometer correctly. Oops. Up. So the first part of the lesson about temperature is called particle party. So unit 2, lesson 2.1. The essential questions here are, what is the kinetic theory of matter? And how do particles move in solid liquids, gases, and plasmas? And this part should be reviewed for you from Intro to Matter. So the kinetic theory of matter states that everything's made of matter and there's movement. So even an atom by itself is going to have movement in it. So the kinetic theory states that all of the particles that make up matter are constantly in motion. So that means even if it's a solid and a very dense solid, the atoms are still vibrating in place due to the movement of the electrons and the interaction between each of the atoms that are next to each other and whatever bonding has occurred within the solid. Oh, the arrow's in the wrong place. So number 5 asks you to describe the difference in the movement of particles in liquids and gases. So you need to use words like faster, slower, held in place, not held in place, straight lines, um, kinetic energy, and that sort of thing. So even at the molecular level, we have movement. So here is an example of water. Water is slightly attracted to another water molecule. And even those atoms, the hydrogen as a green and the oxygen as a blue, even at the atom level, there's vibration occurring. Number 6 asks you a visualize question. And so to me, this screams make a table or a graph. So here's what I did in my notes as I was answering this question, is that I divided it up the little circle because it says just to pick one, but you know that you're going to have to know all three. So I did all three, and then below it, that's where I told how they were moving, how fast they were moving, if they moved past each other, if they moved in a straight line, if they were held in place, that sort of thing. If you remember this graphic from when we did Intro to Matter, we'll be talking about this for a while now. So in the solid, you have the particles or the atoms that are closely packed together and they're not free to move around. They don't have enough kinetic energy to bust out of that solid packed, dense together formation. They're still vibrating, they're still moving. They're just not able to bust out of this tight, packed area that they're in. Then we have liquids. Liquids are free to bounce around each other. They're free to slide past one another, and they're going to, remember, take the shape of the container that they're in. That's why all the atoms here or molecules that are being represented are down here at the bottom. Then you have the gases, which move so much faster. And this is actually probably not a very good representation because there's too many. They go speedy fast. So they travel in the straight line. Yes, they do collide with each other and bounce off, but they have the highest kinetic energy of a solid and a liquid. And then we go to plasma. They are supercharged, going speedy fast. And the difference between these two is that they're going so fast that you have these free electrons that are busted off. Here's another graphic showing this difference between solid, liquid, and gas. Actually, sorry, just a solid. So here you have a solid at a low temperature where you can see you have the atoms in this tightly packed structure. They're not free to bounce around. One is these attractions or these bonds between them. And you can see that here in the medium temperature, that it's still in that lattice form, still densely packed, but they're vibrating faster. And then as they continue to heat up, they're vibrating faster, and eventually they'll have enough energy to break these bonds and go to a different phase. And that's the end of this one.